What we have shown in our previous video is that the first step to determining the distance between the point and the line is trying to figure out the difference vector between b, so the vector that represents our point, and the position vector that represents our line, r. And moreover, we need to remember the vector equation of a line, which is r equals r naught plus tu, where u is the direction vector, r naught is the position vector related to a specific point on our line. So for example, say we know that a point on our line A, and therefore r naught will be the vector joining the origin and that point A for which we know its coordinates. So here we have r naught. And as we have said in the previous video, the reason why we consider the difference b minus r is because it joins our point B with any point on our line. And since we are considering the distance between the point and the line, we need to take into account this difference vector. And we want to impose certain conditions on this difference vector, namely that it has to be perpendicular to our line. I think it's better if we show how to find the distance through an example. So here we have our point B with coordinates 5, -1, and 2, and our vector equation where 20j minus 12k represents r naught. In other words, this represents the coordinates of our point A, because remember our position vector r naught represents the coordinates of our point. And we also have the coordinates of our direction vector u. So to emphasize, this represents r naught, and this represents the coordinates of u, our direction vector. And so I've drawn out the vector u, and what we realize is for the difference vector b minus r to be perpendicular to our line, it actually needs to be perpendicular to the direction vector, because the direction vector is parallel to that line. So first, let's determine the coordinates of b minus r. We note that the coordinates of our vector b will be the same as the coordinates of our point uppercase B, and therefore b will be equal to, in coordinate form, 5, -1, and 2. And therefore b minus r will be equal to 5, -1, 2. And if we write the vector r in coordinate form, we will have -20 in the j hat direction. So in the I hat direction, we don't have anything. So 0, 20, -12. But we also need to add the contribution of our direction vector u. So we will have plus 2 times t plus 4t and -t. Ultimately, we get that our difference vector b minus r will be 5 plus 2t minus 21 plus 4t and 14 minus t. And so note that our difference vector b minus r depends on the parameter t. It's not fixed. It's not a constant vector, which makes sense because we chose any arbitrary position vector r that represents the vector equation of our line. So r can represent any point on the line. And our goal is to choose b minus r such that it is perpendicular to our line and therefore our direction vector u. And that is the essence behind determining the distance between the point and the line. Because remember, I chose r to be over here, but I could have equally chosen r to be over here because it also represents a point on our line. And so r is a variable. Now we want the difference vector to be perpendicular to our direction vector u. And how do we express mathematically the fact that two vectors are perpendicular or orthogonal? Well, the way we do that is through the scalar product or the dot product. And if the dot product between the two vectors is 0, then our vectors are perpendicular. In other words, we require that our difference vector b minus r dotted with our direction vector u is equal to 0. So we already know the coordinates of b minus r, and moreover we equally know the coordinates of our direction vector u. Indeed, the coordinates of our direction vector u is 2, 4, and -1. And the way we got this expression is from here. We have 2, 4, -1, and these are the coordinates of our direction vector u. And so, of course, this has to be equal to 0. And if we write all this down, computing the scalar product, the dot product, well, we get that 2 times 5 minus 2t plus 4 times -21 plus 4t, and finally -1 times 14 minus t. All this is equal to 0. And so I've simplified the expression over here, and what we ultimately get is that -88 minus 12t is equal to 0, which means that t has to be equal to -4. But what does t equal to -4 physically mean? Well, we know in our vector equation over here that our vector r, our general vector r, is a function of our parameter t. And therefore, if we have that t equals to -4, we can determine an expression for r such that the difference vector b minus r is perpendicular to our direction vector u. So let me repeat that because it's important. So we know that r is a general vector that represents all points on our line. But we want to find a specific vector and therefore a specific point such that the difference vector b minus r, which joins the point b and the point r, is perpendicular to our direction vector u. And the fact that it's perpendicular allows us to determine the distance between the point and the line, because remember that the distance is associated with the segment that's perpendicular to that line, because it represents the shortest distance. And therefore, plugging in t equals to -4 in our vector equation allows us to determine a specific point associated with a specific position vector r in order for this to be perpendicular and in order to determine the distance. Now, it's important to note that we don't really need to know which point allows us to find the distance, because if we plug in t equals to -4 in this expression over here, which represents b minus r, then we get that b minus r is perpendicular to u. And if we calculate the length of this vector b minus r, then we have found the distance. But we don't need to know the point r associated with the position vector r such that b minus r is perpendicular. So plugging in t equals to -4 over here, we get this expression over here. And now what we need to do is find a distance. And the distance is associated with the magnitude of our vector b minus r. And the magnitude we computed by taking the square root of the square of the components. So 13 squared plus -37 squared plus 18 squared, which in turn equals to 7 times square root of 38. And that is the distance between a point and a line. In conclusion, to determine the distance between a point and a line, what we first need to do is calculate the general expression of the difference vector b minus r, where b is associated with our point and r represents the vector equation of our line, and so the general expression for any point on our line. And we impose a condition that b minus r has to be perpendicular to our direction vector u, because our direction vector is parallel to our line. And if we impose this condition, then therefore the difference vector b minus r will be a specific vector with certain coordinates. And these coordinates were found using t equals to -4. And hence, by computing the magnitude of this vector, we get our distance. And just as an aside, to find the point P, such that when we draw out the line that joins both B and P, such that this line will be perpendicular to our initial line, to find that point P, what we need to do is plug in t equals -4 into our vector equation over here. And this will allow us to get a specific position vector r that is associated with our point P. And so to be more specific, I will draw that position vector r, which will be over here. Thank you for watching this video. If you enjoyed it, drop the like button, and of course if you have any questions, don't forget to leave a comment down below.